Welcome to week 8 of Math 25. We're doing a turn-in problem from the end of margin and markup and pricing. This is a problem about discount, and there's a missing link in the chain of discounts. So we know that normally a box of special chocolates costs $30. And she knows that it needs to get down to 18. So that's going to be our number at the very bottom. So first she uses a store-wide sale of 10%. That's going to change the price from 30 to something else. And since the person who gave you this homework is polite for once, then the math works out easy. We're doing 0.1 for the 10% times 30 is 3. So $3 removed. Now we're at $27. Everyone okay so far? Then it says she wants to have a second sale. I thought there would be more steps. I haven't done this problem recently. And we're not sure what percentage this is. But she wants to put something in a mailer or whatever that says, this particular box of chocolates not only gets the 10% off the whole store sale, but a special coupon just for that, to bring the price from 27 down to 18. Everyone okay with my picture, my setup? So I'm asking myself, with a percent sentence, blank is blank percent of blank. Remember our Mads Libs game that just sort of helped us approach percents in general? This one was the part. If this one was the whole, or this one is the new, if this one is the original, or this line is the change, if this one is our baseline that we compare other changes to, and then the thing in the middle is always the percent. So I want to play Mad Libs and plug 3 things in, and I have 3 things here. So the thing I don't know is going to be the percent. The only issue is which one is 18 and which one is 27. Which one should I do?
I'm thinking 27 first for the part.
Okay, that doesn't look quite right to me.
Nope, it's got to be flipped. Yeah.
Now, this is both right and wrong. If I do this, I'm going to find out 18 is what percent of 27, and I'm going to get a pretty big percentage because 18 is a lot more than half of 27. So this way as we write it is going to tell us not what percent to take off, but what percent sticks around. And then at the very end, we'll have to do 100 minus that to get the actual percent of the decrease. The other thing we could do is subtract right away and say that this is a change of $9 and say $9 is what percent of 27. But let's go with this method first, since that's what we suggested. So we'll ask 18 is what percent of 27. We'll translate everything. 18 stays a number. Is becomes equals. What is y? Of becomes times. Divide both sides by 27 to get y by itself.
Zero six six six.
So what we found is that this is 67% remains when we go from 27 to 18. So what percent actually went away? That would be the 100 minus 67.
30.
If you're good at factoring, you can see there's just 3 9s in 27. 2 of the 9s went to the 18. The other 9 was what was removed by the coupon if it works the way it's intended. So she needs to somehow publicize and distribute a coupon that says, amazing chocolates, this particular box, 33% off on top of the 10% store-wide sale. Hopefully that's one of the answers. Yeah. Neighbor's yard work is getting louder. Let me know again if it's too loud and I'll move inside. I'll try moving my microphone closer and turn down the gain. Can you still hear me fine?
You're a little quiet now.
I'm a little quiet now. How about that? Better? Okay, I'll go with this. Let me know if it's not working. Okay, other questions? That was a great homework question. Then we'll move on to charge options, which Donna also wants to talk about. So furniture stores are famous for having different kinds of payment plans. I've seen this with computer stores and other places too. And the idea is that the business wants to balance the risk and the reward. They want to sell you an expensive thing, knowing that you probably don't have that much cash handy. But they also want to not take more risk than needed. And there's a chance that they just won't get all their money because you're not going to be able to finish paying for the item. They don't want to drive away customers, so they want to charge more when there's more risk to cover their losses when somebody can't pay them. But they don't want to charge more than they need to because otherwise someone's going to go to the other store. So there's that tension of they have to charge enough to be safe as a store, but they want to give options to people so that the people who can pay things back more reliably don't have to pay too much. And over time, there's 4 different options these types of stores have come up with. The first one is the layaway plan, where after you purchase the item, the store puts it in storage, and it costs a little bit to rent a storage unit and so on. So they, of course, don't go to the same kind of storage units that a household would use. They'd have some big warehouse somewhere, hopefully, but it still costs a little bit. So you have to pay as the customer a little bit of a storage fee. And then you make monthly payments. And because you don't have the item, the interest is either 0 or very small. Because if you can't pay for it, they're just going to say, sorry, you tried. We're going to sell this to something else. It's been safely in storage. There's no wear and tear. So there we go. So very little interest because you don't get the thing until you actually finish paying for it. The second one is an installment plan. So in this plan, as with all the others, you get to take the thing home. So there's more risk to the store because you're going to spill coffee on the couch or get a virus on your computer or whatever else it is. It will be harder for them to sell this thing if you can't pay for it. So you're making monthly payments and you have a small interest rate. And the interest rate can be small because you've made a down payment. So they know they at least have a certain amount of money. They can try and get a replacement item in their inventory to sell to the next person. So kind of there's not that much of a speed bump to their business if you can't pay back for the item. Some stores have a rent-to-own plan that works in a similar way. So small interest rate, you get the item home, but you have to pay money up front so that the store has some cash and can keep doing store kind of things. The third one is a 0 down plan, where again, you take the item home, but you have no down payment. And even more extreme than just not having a down payment, you're going to not pay anything for a few months. But because there is much more risk to the store, you could wreck the item and the store gets no money for quite a while, then the interest rate is pretty big. The last case is a credit card. And the credit card is a similar thing to the 0 down plan in that the credit card company isn't getting anything but your interest, so they have to charge a lot of interest. But they have to charge even more interest than a 0 down plan, because if the furniture store decides you can't pay back, you've missed too many payments, they could always attempt to come and get back the table or couch or whatever it is. Whereas the credit card store just has to send a debt collector, and if you are bankrupt, then too bad on them. So there's more risk to the credit card because they have 0 chance of physically getting the object back. Whereas whatever store sold it to you probably won't get the object back, but maybe. And so there's a little less risk. So the highest interest rate goes with the most risk, which is the credit card. And we might think we have all of these great formulas, a simple interest and compound interest and sum of annuity due. We can just plug in the formulas and use them in this situation, but it doesn't work. None of our old formulas for saving for retirement apply to these things because we're making repeated payments, sort of like sum of annuity due, but we're shrinking. And so unlike sum of annuity due, there's no formula that automatically balances out how the principal is changing and the interest is changing. So we just have to make a table, and that's okay. It's a pain, but we can do it. So actually, let's make this a little less wide. And then paste it. Is that big enough to read?
Yes.
Okay. So I don't know if you have any friends that start up a credit card to pay for something. And every time they make a major purchase, then they just have a different credit card and they close it out when they're done. I actually have an uncle that does this. But it used to be, I don't know how many decades ago, a kind of a more traditional way to pay for things. You didn't want to get your debt out of hand. You wanted to stay organized. Credit card companies were happy to give you a bunch of different credit cards. And so that was the game. You would just use a different credit card for each major purchase and keep track of what you were paying off. So somebody is pretending to do that. And for us, it's just, well, we're in a math class. We don't want to actually keep track of somebody's complicated credit card balance. So this way, there's only one thing happening, and it's nice and simple. The computer costs $3,000. The credit card has nothing on it but that computer, right? So we're just starting at $3,000, nice and simple. It's a 22% annual interest rate. So we know that we have to take that 0.22 and divide it by 12. To find the monthly amount. So this was a per year rate, whereas this side is the per month rate. And if we were back in the previous topic, we would take that 0.018333 repeating, stick it in a compound interest formula, use the 1+ trick, and so on. That should all seem a little familiar if you've done the homework. But in this case, we're not able to use the compound interest formula. We're just going to take that number and use it in the table for each row. I'm out, one moment, got windy. Okay. So that's the 22%. We've now dealt with the $3,000 number and the 22% number. He wants to pay off $400 a month. So that's going to be the same every month. And that problem gave you a hint that when you work out the interest for the first month, it should be $47.67, but we haven't actually done that yet. That's just sort of a help you if you were working through this on your own. So the first month, he doesn't owe interest on all $3,000 because he's going to make a $400 payment. So there's going to be $2,600 left of the principal, and that's what he owes interest on. So for month one, we're going to take the $2,600 and do what with it?
Times it by the 1 point.
Yeah. There's no 1+ trick. It's just we're multiplying by that. If we wanted to use the 1+ trick, we could, and that would give us the ending amount without having to add things back on. So maybe we'll do that next month. But if I do that multiplying, then I get the 4667. I'm sorry, 4767. And so when we add that to the 2,600, unsurprisingly, we'll get 2,647.67. At the start of next month, that's what he has. Right? That's whatever he had unpaid plus the new interest is what he starts the second month with. He's again paying off 400. So he's now down to 2,247. And if I want to find his interest rate, I would again do the same thing. I would multiply it by the 0.00183 repeating. You get 4121. Does it make sense that his interest amount goes down each month?
$13.
You cut it out the end. So
I'm getting 4113.
31, let's see, 2247.67 times 0.018. And I put in lots of threes. Yeah, I think you didn't put in lots of threes.
That's what it is.
And so on. And we have to keep going until finally he pays everything off. So this is annoying. It's not terribly hard. Each step, we're doing a multiplying by the same rate. This rate doesn't change. You wouldn't expect it to change. It's the same credit card. The number you're multiplying the rate by changes because his balance goes down. And then there's a little bit of adding. And then you can carry this number over to the new table row. And you keep repeating. So first I want to say what happens on a test, because this obviously takes forever. I can't ask you on a test that in a normal term would be a timed test, right? This is a funny term, nothing is timed. But normally I would have to write a test that's a timed test. How could I possibly do this? And the answer is that I'm going to give you most of the table, but leave out just a few things. And this is actually very little work. So I'm going to copy this table. Who cares about the word problem above it for now? So this number here, you can just tell me.
3,873.18.
No, the question mark, not the one below it. What did we start with in month 2?
We're going to start with the 485724.
Yeah, whatever we ended with the month before is what goes there. Right? Whatever we ended with the month before is what goes there. So it looks like a math problem, but it's not. These two are just gimmies. And finding the interest due on, that's just subtraction. So that was easy. And finding the interest amount, normally, if you were working forward, you would multiply by the rate. But On the test, you can cheat and you can say, well, I'm going to take the ending amount, subtract that, and the difference has to be the interest. So you don't even have to do any multiplying to get this problem right. So it's kind of wimpy, but on the other hand, it's all I can do. Anything harder than that, I have to make you create the table in a forward direction, and it's going to take too long. So that's one issue, is how do you actually do this on a timed test? The second issue is there some way to see the rest of this problem without wasting our math class going row by row? So if you look at the answers here, then there's a link to a Google spreadsheet, and you can see, aha, it takes him 8 months, and eventually he gets down to 0. The last month, we don't put a payment of 400. He's not going to overpay. He owes only 393.80, so that's what he pays off and he's done. The problem asks us to find his total interest. So we'd have to take this interest column when we're done and add it all up and see what interest he owed. And it wasn't too bad. It was a $3,000 computer, and he pays less than $200 of interest for the privilege of having it at his house 8 months early. If it's needed for his job or school or something, it's worth $200 to not wait 8 months to have it. If you want, I could recreate this spreadsheet. Knowing how to make a spreadsheet is a very useful, employable skill, but this isn't officially a spreadsheet class. So if you want me to sort of show you how this was built, I can, or we can just say, good enough, I see all the numbers. I could have done it with a calculator if we had lots of time. It's just sort of a waste of a Math 25 class to watch people use their calculators a lot. So, anyone want a quick spreadsheet lesson?
When is the time test?
There is no timed test this term. There will be a final exam the last week of the term that, like all of the other things in class, you can see a practice version of, and we will take it at the end. Should I take a tangent about that? I don't know if I've explained it recently. I did at the very beginning of the term. So what happens is when you go to the end of term tests, then there's a no calculator test, which is optional in Math 25. It's a nice way to get a star in your achievements, but you don't have to do it. The one you need to do is the Math 25 overall test. And so you can click on that, take a practice test, look at your answers at the bottom, and every time you load the page, the numbers change, and the problems do a little bit too. So here we're having a prime factorization of 252, but if I reload, now it's 108. And is it always prime? That one might always be prime factorization. Anyway, so the problem is that I can't just have you take one of these at home because you could see the answers. So what I will do is I will, for each of you during the last week of term, assuming that that's the right time. If you have lots of other things going on in week 10, let me know, because we could do this earlier. And I will take a copy, one of these from the website, nothing's different, and I will print out 2 copies of a PDF file, one with the answers for me to keep so I could grade you, and then one without the answers that I will send to you by email. And then you will take your test. So you'll send me something of pictures of your paper, and I can grade your paper. And as it mentions down here, the more that you explain nicely on your paper, the less that we will have a oral exam afterwards, where on the phone or on Zoom, I will say, problem 4, you did well. Can you explain what you were thinking? Problem 9, you made a mistake. Can you find it? Here I have written out a fake way that some other student did 15. Can you find their mistake? Or so on. And so there'll be a few things that you just have to do sort of live by phone or Zoom. But in general, not very much, because people are so good at writing out the steps, they can understand your thinking on the paper. And you can do this more than once. We'll take your highest score and ignore the others. So if it gets to be the end of week 8 or week 9, even though you don't have to do it yet, if you've taken a bunch of practice tests yourself, and when you grade them yourself, you're getting a score you're happy with, then you can say, I'm ready to do this. Any other questions about how the final will work?
Do we have to have all the formulas like on a separate piece of paper?
You don't have to show me your notes. It gives you a few things, like you can see it gives you the amortization table. And it gives you things like for a fictitious type of vegetable, it gives you the yield percent, so you don't need the yield percent table. But for lots of things, and yes, you need notes. And part of your job as the term wraps up is to make your notes efficient. One big use of these practice tests is that you'll say, oh, I forgot to put how many calories are in grams of this or that on my notes. I have to go back and do that. So yes, you'll need your simple, compound, sum of annuity, do formulas. You'll need some example problems. So make your notes nice. One activity I was thinking of doing is making just a blank Jamboard. And as a class, during the class times after we finished with new material, we can just put together a Jamboard that is our record of the best notes. And you can either send me things as a photograph and I could put them on, or you could write on the Jamboard also, or something like that. But we can make a sort of class notes compilation if that helps people have teamwork and working together. Okay, I'm going to go back from that. So the complicated problem for charge options is, let's look at all 4 examples at once. Oops, make that not so wide. That needs to be bigger. Oh, okay. So we'll do this on 4 different slides because it's 4 different problems. Our new person wants to buy a dining room set for $900. He has 4 methods of payment, the 4 different things we talked about above. And he looks around at his budget and thinks $80 a month. That's what I can pay off. So what could he do? He could use his layaway plan. That would have no interest. He would pay exactly the $80 a month that fits his budget. He has a $50 storage fee, but the big problem is he would have to wait almost a year to actually get the thing because it's in storage the whole time. So hopefully another plan works for him. He could use the installment plan. That's the one with the down payment. It's twice as much as the storage fee, but then he gets the furniture right away. He can pay $73 a month, and he didn't have to find that number. The store just tells him, well, for about $80 a month, then we'll give you $73 a month with a 15% annual interest rate that we'd have to divide by 12. He could use a zero down plan. The store has a zero down plan. The interest rate goes up to 18%. He pays nothing for 6 months. That would be nice. But then he has to pay $180 a month. So he'd have to save up $680s so that he has enough cash for when he's paying more than 80, because that's beyond his budget. Or he could just open a new credit card. It has the highest interest rate. He would pick exactly the amount to pay off that he wants. Maybe that's worth it. Everyone okay with the setup?
Yeah.
Okay, so let's start with the layaway plan. So, how many months would he have to pay 80 to have a total of 900? How do we find that out?
Divide.
Yeah. How many 80s go in 900? That's the division. So there really isn't much math here. We already knew he has to pay the 900 and the 50, and there's no interest. So all we really did was notice that it's going to take him 11 months, and then he has this personal decision. He can either scrounge up 20 bucks, which he probably could do over the year, and get it a month early, or he could just pay 20 bucks the 12th month and have it after an entire year. Hopefully he can scrounge up 20 bucks. So that's one plan. It's not his favorite plan, but he could certainly do that. Now we have the installment plan. Now we have to make that annoying table. Let's go back and look again at the columns on our table. So it's the month where you start with, how much your payment is, then you subtract to find how much the interest would be due on, what is that interest, and then what's the ending amount. So I'm just going to take those and save time by not writing them out by hand. This is a good thing to have an example problem in your notes, because any problem like this is going to have the same headings on your columns. Okay, now we just get started. So month 1, he starts at 900, except he doesn't. There's a $100 down payment. So he doesn't owe the 900. How much does he actually owe?
800.
800,
Eight.
because he's paid off 100 of it. He's going to pay 80. So this is already a little awkward for him because he's trying to budget 80 bucks a month. He had to scrounge up the $100 down payment in addition to his first monthly payment, but maybe he can. So the interest is going to be, well, we subtract. Now the interest rate is 15% annually. So we will have to take that 0.15 and divide it by 12. $0.125. It's a friendlier number, no repeating decimals this time. Yeah. Add back on the interest, and we're done with the first month. Questions about that?
That's 125.
So I'm going to make one little fussy thing and erase these equal signs, because it's not true if I say read thing across that 800 minus 80 is 9. So linking all of this with equal signs is relying on my color coding in a way that I don't like. So I'm going to just keep it like that, not pretend that there's actually an inequality that goes all the way across. Okay, month 2, what do we start with? It's whatever we ended with last time. He always pays 80. We'll subtract. So 60 less than 709, so 749. No, 649. Can I do that right? Yeah. I'm writing things wrong. One moment. I think I did it right in my calculator, but I'm leaving out a 0 there. Does it make sense that our interest amount is going down each month?
Yes.
Yes, because the amount we're paying interest on is going down each month. And then I add up those two. And so on and so forth. I think I also want to highlight this 800 to remind us that it comes from those. So I don't want to waste your time filling this out. So once again, we will cheat and go here The layaway plan we didn't really need to make a table for because there's no interest. We did it just easier. Here is the installment plan if we actually watch all the numbers. We started with only 800 and he wound up eventually paying $54.33 of interest. If these numbers don't match ours exactly, then, oops, it's because I made a mistake. I'm sorry, I was brain dead. He's supposed to pay 73 a month. We had him paying 80 a month. Oops. So trust these numbers more if we actually did it. So, but he would wind up paying $54 of total interest. So about the same as the storage fee. And he gets the table right away rather than waiting an entire year. So installment plans are pretty good. That's why they're popular. Zero down plan has him start at all 900 because there's no down payment. He's not going to pay anything in the beginning. So the interest will be due on all 900. We need to find out what 18% divided by 12 would be. .015. So we would get $13.50 for interest. And we end at $913.50. This should look familiar. This is just like the rent increases. We could actually use the compound interest formula for 6 months and see what it grows to. Everything else at the start of the next month, so far it's been smaller because he's been paying things off. But with the zero down plan, he has 6 months of just plain old compound interest. So I'm not going to go through the whole table again. That's a waste of class time. But he's starting at 900. His rate was 0.015. We actually used the right numbers, so it matches. And you can see that after 6 months, he now has to pay off $984. So he's going to start doing that. His payments will be $180. Now this interest due on column starts shrinking because he's actually making payments. And his interest is not like going to bankrupt him, but this is a lot more interest than we did before. He has all of these months of interest where the interest kept growing and growing. It's compound interest because he was paying off nothing. So once he starts paying it off, he catches up at the same year-long thing. These 4 examples are balanced, that they all take 12 months. And he's going to pay more than $100 of interest, more than twice what he did before. So consumers will often think of zero down plans as like a trap. You have to pay more than twice as much interest as otherwise. It's not that the store is trying to trap you, it's just that the chance of someone walking away and saying, I'm sorry, I bought this mattress and now I can't pay for it, is pretty high. So they have to charge a high interest so that the people that make their payments cover for the people that walk away. Any question on the zero down plan option?
No.
Okay, we're almost done. The last choice was to say, I'm going to ignore the store. I'm just going to get a credit card. It's easy to get a credit card. I'll use it only for this one purchase. So our interest amount is going to be higher because it's a credit card. And that's not because they're mean, it's because they can't take your furniture back if you don't pay. This is that repeating decimal that could be tricky. So he starts at all 900, there's no down payment. He pays the 80 he wants. Remember to put lots of threes in your calculator or you'll be a few cents off. Not a big deal, but oops, why did I do 720? I'm sorry. That should be an 820, shouldn't it? I am still thinking from the one with the down payment. We'll keep going like this again and again. And again, I'm not going to bore you and have you watch me use a calculator for hours. So if you were to keep going with this process, subtracting over here, multiplying over here, adding over here, then it would look like this. And what surprises many people, because we've been told all our lives that credit cards are bad, is that the interest is less than that zero down plan. Remember, with the three sisters and saving for retirement, starting early really helps. So even though the interest rate was higher, because we started paying off right away, rather than having 6 months of no payments with the interest rate growing or interest amount growing and growing, then starting right away brought the interest down. So we don't know what's his name? Fendrick. We don't know what Fendrick actually will do, but we can see the pros and cons. If he wants to pay the very least amount, he can do the layaway plan. But that's kind of stupid because it only costs him $4.33 more to do the installment plan, and then he gets the table right away. But that's not quite true. He also has to scrounge up $100 right at the start. Maybe he has a friend or a family member that will help him do that. If he can't scrounge up that money and wants it right away, then he should open a credit card. He will pay less interest for the credit card than the zero down plan. And only if his credit rating is stretched out thin enough that he can't open another credit card, then the zero down plan is sort of the last option. So for which option is best for him, then there we go. Okay, that was a lot of tables. Questions about anything we did?
No.
Yeah, David, could we look at the very first one again where you wrote down the $50
Yeah.
fee at the bottom?
$50 fee at the bottom. That one? There wasn't really any need for
Yeah,
a table
this
there.
one.
Yeah. Or did you
I'm
want?
just curious as to, well, we didn't really use the 50 in our math, but you wrote it down at the bottom.
Mhm. Yeah, because it doesn't come into the
I just-
problem until the end. It's just sort of, he pays the $50 up front, and then that's it. It doesn't make anything change. It doesn't make it interesting. It's just 950 total. The only really interesting thing about the first option is if he can scrounge up the 50 bucks to start with, because we don't know that. And at the end of week 11, not week, month 11, can he scrounge up 20 extra bucks to just finish and pay off all 900? Or will he have a month number 12 with a $20 payment? So that might matter a lot to him in real life. It's just not very interesting as a math problem. I should also comment that all of these are assuming he doesn't just have $900 cash, right? If someone could just pay money and buy it, then that's not really a math problem either. That's just you go shopping. Okay, but that's how these work. Subtract, multiply, add the two things, move on to the next row. Read the problem better than I did. So if I had these cute little plastic spinners, then I could actually print out copies of these shapes. And you could put the plastic spinner right on top with the spinner centered and do a spinner game. But you just have to kind of imagine that because we're social distance learning. So our last topic is likelihood. We're not going to be able to finish it in 20 minutes, but we'll get a little bit into it. Since we didn't have questions on margin and markup and that, but we did have a question on discount. Never mind. No new homework will be due. So just same as before. But we'll start likelihood. So the first thing is we want to kind of understand probability a little. And spinner games are a nice way to do that. So if we have a very boring spinner game where half the time the spinner points into a +1 and half the time it points into a -1, then maybe Timothy and I are playing, and if it points this way, he gets $1 and I have to pay him, and if it points the other way, I get the $1 and he pays me, or something like that. Right? Maybe it's at a carnival, but this would be really boring. Once you're older than 2, no one would play this because it's just too obvious that it's all based on luck. You're going to either pay $1 or gain $1 half the time. Who cares? But this introduces the concept of fair. If we played the game a whole lot, so the good and bad luck streaks cancel out, you wouldn't expect any change of money. Right? If Donna and Timothy played this for an hour, then they would be really bored, but they'd probably have the same amount of money they started with. You wouldn't expect anyone to get ahead if the winning and losing balances itself out so well. So your first challenge is what happens if the numbers aren't the same? So where could we make the lines to divide the circle up into regions so this game is fair? If I made my line right down the middle again, then that wouldn't be fair. We're going to come out ahead because we're earning $2 the same amount of times as we're losing $1. So overall, we're going to get a nice income.
So shouldn't the $2 side only have 1/3 of the spinner?
Yes, if I make things thirds, we kind of imagine that there's the other third here. Then there's 2 chances for us to land in the pay $1 for 1 chance to land and they gain $2. So if we do this a lot, we'd expect we'd win $2, but then twice we'd have to pay the $1, and then we'd win 2, and twice we'd have to pay the $1, and so on. So note that the payouts as positive numbers, if you know the phrase absolute value, you can use that, but I don't care. Sum to 3. So we used thirds. We need 3 pie slices, even if we don't really see them all, because 2 and 1 make 3. Everyone okay with that? If it helps, I could say this is like the good region, and this is like the bad region.
Sorry, I gotta turn off my computer. It's being stupid. It's flicking
Okay.
on and off. Sorry. Fucking hate this computer shit. Yeah, turn it off.
Ready for the next one? It gets a little trickier.
Yes.
Okay. So, ta-da, there's our answer. Okay, where will we draw our lines this time?
So we would want the 3 to be single and the,
3 is single.
we would third it again.
It's not thirds again. I got a text chat that somebody said quarters. So as before, if we turn these into all positive numbers, then the sum is 4. 3 and 1 is 4. So we use quarters. So I'm going to make challenge my own artistic ability drawing on this tablet. Okay. So as before, we'll draw that and just sort of imagine the other quarters. We have the quarter we like, where we get 3. We have the 3 quarters where we'd have to pay $1. And each time all the quarters are hit, because eventually, if we do this, we would expect the spinner to hit all 4 quarters equally, right? The same number of times in each one. And we'd get +3 one time, and the -1 3 times. So we'd get 0 overall, and that's fair. So, ta-da. Ready for one more before we're done for the day?
Yes.
Okay, this is as hard as I can make them without driving people crazy. So use the same idea before, that if something has a bigger effect, then we should have it happen less often. That there's a balance between the likelihood something happens and how extreme an effect it has, if we want things to be fair.
It still should be quarters, right?
They do add up to 4, but now we have 3 things. So talk about it with yourselves. Crystal's putting things in chat.
Shouldn't the ones both get 1.5 of a square?
We know this one is going to be the biggest wedge by far. It has to balance out both of the other numbers. Should I go with what we have in chat? Should I try drawing that? Do people have other ideas before I start drawing?
6 squares?
So what Crystal suggested in chat is we make fifths, which would be hard for me to draw, but I will try. 1. Mhm. So there's fifths, more or less. So as the spinner lands in all 5 of these places, how did I phrase it? Each time all the fifths get hit.
Would they have to all be -1?
So we'd have a +2 oops, that we like, and a +1 that we like. And then we'd have a -1 and another -1 and a third -1. So that is indeed 0 overall and fair. If you want to see it drawn slightly better, then there we go with actual fifths instead of my thing. So how did we know it was 5? Because 2 + 1 + 1 isn't 5. We can tell now that it works, but how did we get it if we didn't know?
That, because that's how many times it could be down.
Yeah, we sort of add up the positives.
Go
Each of them can have one wedge. It doesn't matter whether they're a +2 or a +1. Let's give each of them one pie slice. So that's a +3. And then we need as many negatives as balances that. So think which if we look before is why we were summing to 4, that we have the 3 got one slice, so we need 3 minuses to balance it. The 2 had one slice, so we needed 2 minuses to balance it. So as long as the minus is 1, then that's a more general rule. Okay, none of these are on the final. Why did we do this? Because we're going to be doing something later on with this kind of problem where something in a class you have certain scores, but they're not worth the same amount. Your attendance is worth less of your grade than the homework. The midterms are worth less of your grade than the final, and so on. So we haven't done this sort of average before. We've done mean and median, but in mean and median, everything counts the same. It's not true that one house on the block is for some reason the showcase house, and for home values in the neighborhood counts extra. So This is called a weighted average. The weight of the different categories are not the same. The weight of the different items we're putting together aren't the same. So here, the weight of the different things aren't the same. So this is a warm-up for your brain to get used to thinking about what happens when we're putting things together that have different weights. And the goal isn't to make spinner games, but the goal is to do the weighted averages. First, we're going to talk about probability when everything is kind of straightforward. We're going to roll dice and add up the numbers. And there's many more ways to get 7s than 10s, and there's even more ways to get 10s than 12s. But the dice are fair. There's nothing kind of funny happening there. Then we're going to talk about a gumball machine where gumballs come out. We're going to use the same things about odds. Odds are different than probability, unless you are someone that bets on horses or is taking an SAT test. You probably don't care about odds, but we'll talk about odds quickly anyway, just so you know. And then the one that might really affect your life is there's a difference between absolute change and relative change. So we'll talk about what those words mean and how people can not lie with statistics, but pick which statistic to use to try and convince someone that their policy is good. So it's like the choice of mean and median, that what counts as typical, what counts as average is different if you use the mean or the median. And the same is true for changes with absolute change and relative change. So this is like mean and median, a heads up that when are people lying to you? When are you reading a newspaper report and you're thinking, why are they talking about home values using the mean? They should use the median for those. Or when they're talking about incomes, should it be mean or should it be median? Both of them have reasons for policy and so on. And then the weighted average thing that we talked about. We'll do an example problem and see how that works. So we're close to done. We'll probably finish up next class. And then all of week 9 will be review. And week 10, we will continue having class as usual. Some people will just not care because they'll have taken the final and be done with it. And others will keep going to class and we'll have review days in week 10. And you'll take your final at kind of the last minute. Remember, you can take the final more than once. So whenever you want, start doing practice finals, grade yourself, see how you're doing, and transition from worrying about homework to worrying about the final. Anything else before we're done? Oh, okay, so study session today at 2 o'clock. Maybe I will see you there. The saving for retirement is due today, so get that in some code or another, even if it's not 80% before the end of the day if you haven't yet. Nothing from the business decisions has a due date yet because we had questions on that homework at the start of class today. So maybe see you at 2 o'clock or see you on Thursday at class.
Thank you, David.
Thank you all.